WLAN basic network planning. Objective upon completion of this course. Okay, so here we have the basic process for WLAN networking planning. List factor interfering WLAN signal. Describe WLAN balancing methods. Content. The first content, WLAN planning process. Development process. So starting on the top here is a specified requirement. Okay, so this is one will be the first step we will require to do. And the next one will go to the conduct on-site survey. So we have to go to the area there and do some site survey. Then after the site survey, make the development plan. So then we try to pass the development plan, okay, and match to somebody else, okay, to confirm it. Is it the plan is approved? If the plan is rejected, then you might need to replan your the planning again, okay, until it's approved. So once it's approved, now we can process to the installation, the device installation. After fully installation all the devices, okay, already deploy all the controller, the AP, the switch, the cabling, everything is already done. So now we can try to do some the acceptance test. So after every test is already done, so you see the project is accepted. So when everything is done, then we can complete the project. So this is all the entire roadmap. Basic requirement for WLAN network construction. So include the area and deployment method. So we have to focus and understand what is the application, the scenario. Field strength requirement. Okay, how strong of the signal strength minimum and the maximum is required. The networking mode. So right now on the architecture, the networking design, they require the connection is using the layer 2 or layer 3. The forwarding mode, is it in the direct forwarding or they prefer the tunnel forwarding. Then the follow-up have the power distribution mode. So this more is using for the AP. So is it the AP got the PoE support? If yes, we can use using the normal LAN cable to connect them through from the PoE switch, or else you might need to figure another way to solve this problem. Then the last one, it will be the bandwidth requirement. So what is the bandwidth required for every single SSID? We're going to start on the site survey. For the site survey, first you need to have the floor plan. Okay, so this is the map showing the company. So they show a lot of the block, okay, and the buildings, and it's recommended using some of the apps, okay, can able to scan the wireless, or you can bring along with your laptop with some software installed. Okay, go to the area there and conduct some survey. Try to scan the wireless signal and how many channels is being used in that area. Next, coverage mode. So the coverage mode, by giving example for the indoor sector deployment, so we have to understand what is the coverage required for this building. Is it the full coverage, or they have any restriction area is not allowed to have the signal coverage, especially in some of the scenario like hospital, okay, because they have some room, it's not allowed to have the wireless interference. Then the next one, indoor distributed deployment. So when we're using the indoor distributed AP, we have to understand what type of the accessory, the connector, going to use. Because on the previous slide, we did do some explanation about the distributed AP. Okay, there for those accessories, the coupler, the splitter, and many others. And the last one here is the outdoor coverage. So the outdoor coverage, you need to understand about the deployment, the way to adjust the angle of your AP, choosing the right antenna. Follow-up will be the channel planning. Okay, this one is for the 2.4 GHz frequency band. So understand your country and what kind of the frequency band can able to use. Okay, this is a channel. So most of the country can support the channel 1 to 11, but of course also has some other country it doesn't support. Okay, so this is the table. And the next one is for the 5 GHz. So the 5 GHz have the channel from 36, and we can use until the channel number 64. Of course, they also have another, the band, the UNII band 2E. It starts from the channel 100 to channel 140. Okay, but the kind of channel will be less using. Okay, it's mainly deployed for those of the outdoor project. And this is for the channel binding. Channel binding is more often configured on the 5 GHz frequency band. So to understand which channel can able to use, and you choosing the right channel. When installing the indoor setter AP, so when too many AP deploy and there's a lot of the overlapping happening in the same floor, so we need to consider about those of the channel selections. Okay, because sometimes of the auto channel selection, it doesn't run very well. So sometimes you have a lot of the same channel occur in the area. So to prevent this happen, so you can try to do the manual way, changing the channel. So, and those is the overlapping channel is recommended to use 1, 6, and 11. Then the next one is for the 5 GHz. And this one is for the building. When the company, they have several floors, it's not just one floor. Okay, they have around like 7 floors right here. This is the example. So to minimize the cross-floor interference, so you need to consider about the upper floor interference and also the down floor interference. The two places you also have to do some scanning. Okay, understand about the channel allowed to use. Try to using the least crowded channel become your on channel. And this one is for the channel planning for outdoor APs. When the outdoor AP using the omnidirection antenna, so that means this is the omnidirection, 360-degree coverage. Plan the channel according to the plan for installing indoor setter APs. When the outdoor AP use directional antenna, plan the channel in combination with the area direction to prevent interference between AP at the same frequency in the same overlap. So the example right here is showing one AP with one antenna. Of course, when there's only one AP and one antenna, you can select any channel that you want. Okay, now they have one AP with two antenna. So one AP with two antenna is still fine because those signal strength is broadcast come from the same AP. So anything they broadcast from the same AP, basically they have no interference. Okay, it will be safe. Then the next one, when they have two AP with four antenna. Okay, so this one is actually mean they have two AP. So I have AP1, okay, and then I also have one more is the AP number 2. Two AP. So two AP, they actually come with the two antenna. So AP1, AP2. Okay, they actually deploy together at the same pole. Okay, this is the pole they stick together. And then they have the antenna. Okay, two antenna. And both of those antenna, right, is the omnidirection. So they cover the surrounding with a very wide area. So to prevent the interference, the AP number 1, these two antenna, you can using the same channel. Okay, AP number 2 can using the same channel, but it's different channel than the AP number 1. So try to avoid the channel interference. Then the next one, 2 AP with 2 antenna. Each AP have only 1 antenna, so just make sure 2 AP using the two different channel, then you can able to avoid the interference. 3 AP with 3 antenna. Each AP with only 1 antenna. So every single channel you can use is 1, 6, and 11. Make sure they're using a different channel. For the 4 AP, 4 antenna. So understand about the channel. Okay, so they have no. They might have one of the AP will have the interference. Okay, because you have no other channel you can able to use. So you can try to choose either one of the channel. Okay, like example right now the deployment channel 1, channel 6, and they have 2 channel 11. Follow up, you have the networking design. The networking design, okay, the first one they have direct forwarding in inline mode. This AC will have the uplink and also the downlink. The downlink is connected to the AP directly, or they connect through the switch, then link together with the AP. So right now the forwarding is using the direct forwarding. So to understanding the configuration of the VLAN and what type of the link type you have to choose. And the next one is called tunnel forwarding in the inline mode. So basically, the configuration is very similar compared to the previous one. The only difference is the user data right now will be sent through the tunnel here and go back to the AC. Okay, so the next one, the direct data forwarding in bypass mode. So in the bypass mode, only the measurement frame used by the controller or the AP, the access point, will be delivered into the tunnel. The user data can bypass the AC, so the traffic can go directly to the gateway and to the internet. So it doesn't require to go back to the controller, except we're using the tunnel data forwarding. The tunnel data forwarding, not only the management frame, the data frame, those of the service data using by the SDA, all have to return back to the controller, and then the controller will handle all the packet and forward to the internet. So in this case, then the AC, you might need to configure the default route, or else all the route will lose the gateway. Capacity design. Data service. When we're using for the web page browsing, email, online chatting, web broadcasting, online news, or online shopping. So the downstream can set to 2 megabit per second, and the upstream bandwidth is 256 kilobit per second. Okay, of course, these are just some of the recommended. Okay, you can adjust this to anything that you want. For the SOHO enterprise network access and also the high-speed data transmission, the downstream bandwidth we can set to 4 megabit per second. The upstream adjust to the 512. And the last one, for the multimedia, video conference, video call, web TV, remote education, and SDTV. So all the data services here is those of the live broadcasting, is like those of the streaming. So when they're doing the streaming, basically they require to have the equal speed for the downstream and also the upstream. So this is the reason why you notice here the bandwidth is the same, 2 megabit per second for both. And the last one, the HDTV. Then the HDTV can set it to 15 or to the 25 megabit per second. The upstream adjusts to 1 megabit per second. One AP is sufficient to provide the signal coverage in common office. When there's too many users, okay, the concurrent user now is increased, or maybe they have some expanding for the building, so they expand the office, and now they have more user is going to connecting through the internet through the Wi-Fi. So you need to using more AP to prevent the overload. AP deployment position. So for the AP deployment, also have to concern about this problem. So when we deploy the AP, take note, when we put the AP right in front the door, okay, example, this one is the hotel building, okay, they have one room, okay, they have total of 6 rooms. The AP deploy right in front the 2 rooms here. So when they're doing this kind of the position, so the AP, the coverage will cover, okay, they can able to cover the room at the top and also below here, should be no problem. But when the signal is try to pass through to another room, so needing to go through 1 wall and 2 walls. So when the signal reach to the corner room, the signal strength may be decreased. It will be decreased. So for this kind of deployment, some of the room they might not able to get the very strong signal strength. Okay, so this is a problem here. To solving the problem, you have to using more AP. Like example, adding one more AP right here to cover the bright spot. So this one, they're going to cover those of the bright spot. Okay, cover here. So the well deployment, we can try to adjust the AP. The AP put is just in between the 2 different rooms. Like example right here, because the signal strength can able to pass through 2 different rooms, we only go through 1 penetration, like this. It's just 1. So each room also have a very good signal coverage without using so many AP. In the area requiring roaming, 2 neighboring APs should have 10% to 15% signal coverage, okay, for the overlapping area. So the SDS can switch between the AP seamlessly. So we have to do this on for the overlapping area. And if an AP is near to support column, okay, there will be the signal shadow behind the column. So actually it's behind the AP. They have some of the signal strength. Okay, they also have some the radios. So when the locating the AP, consider the signal shadow. A metal will cause high signal loss. Do not place the AP or the antenna behind the metal ceiling, because the radio waves also is one type of the electromagnetic. So when the radio hit on the metal object, the metal will going to absorb all the signal strength. Okay, try to prevent this. In important area, add AP to strengthen the signal. And this one is the Huawei WLAN planner. Use Huawei eSite WLAN planner to emulate the field strength and throughput and adjust the AP position based on the simulated signal coverage. So this is another simulator, okay, developed by Huawei. So they allow you to import the floor plan inside and do some simulating. So right here they already have many different type of the AP Huawei. So for more, you can click on this arrow key and select another type of the model. Okay, so you just deploy the AP in the room that you want, and then you click on the simulate. So they will show you the result. So the purple color will show the result. This is the very strong signal strength. So the signal strength can be up to maybe minus 30 to minus 40 is the purple color. Anything is beyond to green color here is already become weak, but still fine. It's just like minus 50, minus 60 only. Content number 2. WLAN signal interference. This is the penetration loss. So they show the different material. When the radio signal, the wave pass through the glass window, for those non-tinted, it will lose 2 dB. The wooden wall will be 3 dB. Depending what kind of material, different material, the loss will be different. Of course, when we're using the frequency band is a 5 GHz, they will cause even more the high loss. For the call channel interference, so try to avoid the two nearby AP using the same channel. If you know the AP is actually very close to each other, and both of them can able to detect the signal strength come from another AP, try to avoid using the same channel. Not only for the call channel interference, we also is not allowed to using the adjacent channel. Example, channel 1, channel 2. Channel 2 is too close to the channel number 1 because each channel occupies 20 MHz. And the channel number 2, they have around like 15 MHz will be overlapped to the channel number 1. So we are not recommended using the adjacent channel. Try to use channel 6 or channel 11. Other interference might come from the microwave oven, the colorless phone, and some other Bluetooth device, the wireless camera, and the router. Content number 3, load balancing methods. So currently the IEEE 802.11 does not provide the specification on load balancing. However, the following problem will occur due to lack of load balancing. Reduce WLAN efficiency and performance. This might happen. Increase the network congestion risk. The poor resource utilization. Huawei provided a series of advanced load balancing methods to prevent this problem. With these load balancing technologies, so you can make a full use of the wireless network. The basic principle here. The roaming will be triggered when the SDA now is already inside the overlapping area between the AP number 1 and AP number 2. So, and another one will be this. When we want to perform the roaming, you need to make sure the PC is in the coverage area on both side AP. Right now they have so many AP. The AP 1, 2, 3, 4, 5, and another AP, the PC SDA is located on the AP number 2. So if the AP doesn't inside the overlapping area, you can't able to perform any load balancing. Even we already enable load balancing, there's no effect on this scenario. So balancing AP load to ensure the proper access from SDA. The mode for load balancing, they have static load balance or the dynamic load balancing. They have two different types. The most recommended selection here is the dynamic. So this is the static load balance. A load balancing group is manually created. So the administrator, to configure the load balancing here, you need to manually to configure the group. Like example, which AP is allowed to perform the load balancing. So maybe they have some very strict policy in the environment, so they will not allow the user perform the load balancing because basically when we're doing the load balancing between two different AP, they will cause some the packet loss. When you're doing some video conference or the voice over IP. To prevent this happen, so they recommend using the static load balance. So for the static configuration, they only can support up to 16 members. This is the maximum that we can configure. So the most easier way we can using a dynamic is pretty simple. So the AC add the AP that report the same SDA to load balancing group, and everything will be done automatically because, like example, the SDA is inside the overlapping area. Both AP will receive our probe request. If you still remember this one, our PC, after we turn on the wireless, it will periodically send a probe request. So this probe request is a broadcast form, as long as the device within your broadcast range. So all the devices will receive it. So now the AP1 and 2 receive the probe request, and it will going to deliver to the controller. So now the controller receive this information. They know right now the AP number 1 and AP number 2, both of them are able to connect it to the SDA6. Then I know they can support the load balancing in this area. So the the controller here will automatically add these 2 AP into the load balancing group. Okay, summary. WLAN planning process. WLAN interference factor. And the last one is load balancing.